Hey, Dan, can you hear me? No?
Okay, I'm just going to get started. Thanks for having me. Most of you probably seen this quote before. It shaped an entire generation of technology, and the technology really has started to move fast, hasn't it? But engineering is one profession where we can't afford to break things. When engineering fails, the consequences are physical, public, and permanent. AI gives us the ability to reason, generate options, and explore solutions at a scale that would have been unthinkable even 5 years ago. But trust, verification, validation, accountability, they don't scale at nearly the same rate, especially in an industry that has historically been slow to adopt change. Building project cycles can take years. AI hype cycles happen on the scale of weeks or months. Meanwhile, the work keeps coming and our people still need to deliver trusted results in real time. I've spent the last 20 years trying to automate away the typical, repetitive, and frustrating parts of our work so we can focus on the meaningful, creative problem solving and actually find pride and joy in what we do every day. But I also understand the weight that every process and every decision carries on the quality of our outcomes. Because in engineering, details matter. 5 or 6 years ago, I started building a team to improve our AI readiness, to challenge the status quo and explore how emerging technology could responsibly improve our digital delivery. Not to move fast and break things, but to move deliberately and reshape the delivery process from within. That's what I want to talk about today, engineering intelligence. How we can amplify expertise, avoid new kinds of failure, and responsibly transform our practice. I'm Dan Reynolds, AI leader at Walter P. Moore. We're about 1,000-person engineering company with almost 400 licensed professionals and offices around the globe. I started in enclosure engineering and now lead AI initiatives across all of our practice areas. This journey started small about 6 years ago. We've been growing the team ever since, and now it's a significant part of our digital investments. I'm not going to claim that we got everything right, but that's given us a lot of experience and a lot of preparation to navigate today's challenges with artificial intelligence. So let me talk first about how we've tried to amplify the expertise of our engineers, what we've done, and the promise that's there. This is our team. We have people across digital practice, engineers, computational designers, and now AI developers. The ones highlighted are full-time dedicated to innovation. Not everyone is. For the most part, we remain practicing engineers working on projects. We're scattered across the globe, mostly concentrated in the US, largely in New York, DC, and Houston, where our corporate offices are located. But we have people in different offices everywhere. We're a very virtual company and team. We leverage the skills that each of us brings and embed ourselves into the work of those different offices. Even just thinking about New York, we've contributed significantly to digital efforts on project developing tools as we go. A lot of web applications, really driving adoption through hands-on use in our office while contributing to global efforts. A lot of our work happens on projects. These can be like prototypes because we sometimes have very custom needs for a particular project. They don't always translate to a solution that everyone can use. But as they mature and generalize, they start to become accessible to more people. We've tried to create a culture that leads to adoption based on the situation you find yourself in on a project. We have plenty of people who can create custom solutions and others who have very specific needs that determine when they'll adopt the tool. We follow an agile development pattern, and we've nicknamed these stages with symbols, from a skateboard all the way up to a car, depending on how mature the product is. We make these tools accessible to everyone in the company through an innovation funnel, and we outline how mature each particular product is. We've long anticipated that some tasks are or will be replaceable by automations. We welcome those opportunities where they prove useful and lead to enhancing the quality of our staff, strengthening what we deliver to clients, and improving project outcomes. We've been preparing our staff for that mindset and actively brainstorming the ways we'd like it to work for us. 6 years ago, we noticed that tools come in many different forms. A lot of them are Excel spreadsheets, sometimes MathCAD sheets, sometimes automation routines in Grasshopper or Dynamo scripts. A lot of these little solutions that people develop on a project, but they're stuck in that particular form. At the end of the day, we think of all these as functions. Like in mathematics, you can abstract a function to represent any equation. We've done the same thing with this product we call Emulation Lab. No matter where a solution is written, whether it's Excel, Python, or a custom app we develop, we just think of those as functions. And similarly, when we want to deploy those into products, we don't really care which products are using them. That has allowed us to operationalize these functions and make them accessible across many different platforms. They're available on the web. You can access them on mobile. You can even chat with them. But when we showed this to people, they didn't immediately see the value. I think they were just too busy with deadlines and not ready to invest personally in learning a new tool that they perceived as a direct replacement for an old tool. So in order to demonstrate the power of what we could do, we had to show an example, something more impressive than just a replacement for an existing tool. There was a spreadsheet that would check if a retaining wall design was acceptable. There were a bunch of different parameters to consider, and we used that as a starting point. Once we built this optimization routine, we challenged 2 engineers to see if they could beat the optimizer. The optimizer was dramatically faster than either engineer. The engineers on average took about 20 minutes. The optimizer was significantly quicker. And it gives us this deep understanding of the design landscape. We're able to calculate these things super fast, so we can understand our design options and constraints, in addition to finding the optimal solution. Even calculating the entire design map took less than 10 seconds. So we can give much more information to designers as they work. We can also consider many different conditions. In this example use case, we were able to take all the different conditions, design them, and create the full schedule in less than a second. I think this really won credibility with the engineers. And from there, we started to build many different collaborations. All of these projects were done working side by side with different groups. We have at least one example of collaborations that we've done with all different practice areas. They range in type and application. Sometimes the end user is working in Grasshopper, sometimes Revit, or they even incorporate functions into custom web apps. We're completely flexible. We let these different groups take ownership of the functions and the end usage that they want to achieve. But we can help them make the most of the technology. So we built this infrastructure for taking functions, regardless of where they were written. Each engineer can contribute in their own way, and then we distribute those functions to various applications and end user environments. For example, Project Lightning was an application being developed to streamline the design process. It uses a mixture of various functions, machine learning, and catalog lookups in order to design entire systems. Here's an example of what it looks like in action. It can pull in different design contexts from various formats, whether it's a PDF or Revit model, and then work through the design process efficiently. This is aimed at gravity design. We have other apps for doing lateral. So this is helping streamline just one aspect of what we do. While we had a planned and incremental approach to incorporating various forms of AI and machine learning into our work processes in a way that was manageable for us, we were thrust into an entirely new reality when ChatGPT took the world by storm in 2023. And it introduced, I think, a new way of working with many benefits. But at the same time, it also introduced a lot of new risks that we had to come to terms with. A few months ago, one of our managing directors who actively tests emergent technology for us sent me a function for designing a spread footing that he was able to generate from his phone while shopping within 30 seconds. While the code looked reasonable at a glance, it actually had a lot of problems. So I'd like to take some time to walk through some of the potential pitfalls that we see and that we're helping our company to navigate. I think it's important, first of all, that everyone understands a little bit about how these language models work. Each sentence is translated into something called tokens, which are roughly words or parts of words, along with a few other special tokens. Then they pre-train from patterns of language used on the internet, books, or other sources to identify patterns. When I say the sky is, you may already predict that I'm going to say blue because it's such a very common phrase. But underlying all of this behavior is just probability. There have been various attempts to understand the way that these models think, and how you can control and evaluate one model versus another. For example, an SVG is a picture that's defined by text. So you can have a language model generate an image based on defining the text. Simon Willison has this famous blog where he compares all the different language models. There's tons out there, but he compares these different language models by how well they can represent a pelican riding a bicycle. And some of them do much better than others in terms of that interpretation. I've never seen a pelican riding a bicycle before. I don't even know if I'd be able to draw it, but these are very interesting interpretations of that concept. Some of them get the bicycle better and the pelican better, but it physically couldn't happen. So it's kind of an interesting and clever test. But as engineers, we don't really care about that. We care about how well it can perform engineering tasks or understand engineering related concepts. So we wanted to see if an AI agent could pass the PE exam. It's not a very easy exam for a language model to pass. We had to wait a while before we had these multimodal models that could understand images, because images are a big part of the exam. If you think about it, you have to understand the question, the options, you have to understand the figure, whatever is supplied, the variables, what they mean. And then you need to know what to do, what calculations to perform, and then execute a series of formulas and equations that are needed to solve the problem. We finally, with GPT-4o, were able to witness a model that could answer questions correctly. So then we started looking at more models, and eventually we found a few. Very recently, just a couple months ago, we found several that could pass. Typically, about 70% would be a passing rate, although this is not published anywhere officially. But essentially, this is the exam that's used to judge if a graduate engineer can become a licensed engineer. Usually, where these models break down is actually in the vision component. They've gotten very sophisticated in understanding the code requirements and the procedural math required to solve those problems. By the way, this is normally an 8-hour exam for humans, but I guess you could have the LLM do it for about $20 and at a fraction of the time. Several of you may note that it's wrong 30% of the time. And yeah, that's kind of surprising to think about, right? That it's acceptable for humans to be wrong 30% of the time. And I'm sure that these models are going to be getting better and better at doing it. So maybe, we should be thinking about what's going to happen when these models are wrong only 5% of the time, or even 1% of the time. Does it really make the situation any better or any different? It might just make it harder to recognize when they are wrong. Will we be able to catch those mistakes? What can we do to prepare? We use a lot of tools in engineering, and one of the tools that we use is finite element analysis. Our chairman of the board has this training program where he emphasizes your model is wrong, but sometimes it can be useful. He's talking about a finite element analysis model and how to be critical of the results, because there are numerous ways that an FEA model may look correct, but misrepresents the true physics that we're trying to represent numerically. It's a representation after all. There are many different ways that it could be wrong, even if it looks right and gives results. You have to be critical and you have to know how to anticipate ways it can go wrong. And I've developed an intuition through the years to be able to catch some of those errors and ways to check it. But we don't really have those for AI yet. Regardless, I could say the same exact thing about AI. Your AI model is wrong, but sometimes it can be useful. I think we need to ingrain that in our minds because even if it produces something that looks right, it can have a lot of errors. That spread footing function, for example, 30 seconds to generate, looked believable. It actually took us a month to troubleshoot the script and make sure it was validated and correct. We basically had to rewrite the whole thing from scratch. And part of the reason it took so long is that when communicating about the tool, it kept being referred to as an AI tool. What does that mean? What role is AI doing in the tool? Is there a chance it hallucinates and gives unpredictable results? It almost seemed like AI was the author, and we're just supporting roles in this co-creation process. But we need to be more than that. If we just say AI did this, it sort of implies that we're deflecting blame for anything that happens as a result. AI makes mistakes, but we can't. Our users can't. This shouldn't be an AI tool, even if AI was involved in the co-creation process. Once it's tested, validated, and deployed, it's a regular tool. It's not an AI report. It's your report, and you need to take ownership and accountability for what you are producing. Use AI as much as you want. But in the end, it's your report, and you need to be accountable for what it does. And that's exactly what we expect from the engineers as well. All engineers remain fully accountable for what they do, regardless of what tools they use to get results. Now, as we allow more and more autonomy from agentic processes, we have to think about how engineers can be accountable. It's not enough to just say that they must be accountable. We need to give them the opportunity to investigate and to see what's happening under the hood in a way that they can ask the right questions and get real answers. They need to know exactly which parts were AI generated and which were done by a validated tool. They will want to be critical of all the tools and all the results to make sure they match with engineering judgment. But this transparency will be a key aspect of adoption. Remember that trust is really hard to gain, but super easy to erode. Once you lose it, it's really hard to get back. We can't expect engineers to completely question the validity of each tool. There isn't any benefit to that. So given that we can potentially amplify our engineers in their work, or if not handled correctly, we can introduce risks that put their work in jeopardy, how can we transform our practice for the better? We're going to need to rethink a few things. First, let's rethink design. We showed you at agile development stages from skateboard to car, but the AI team also builds concept cars. These aren't about what's practical today. They're explorations of what's possible. These ideas can be far-fetched, even provocative, but that's the point. We're challenging the status quo and asking, what could engineering look like in the future? For example, we had a product that's under development called Trace. This is for lateral design. The particular task at hand is placing shear walls. We proposed a method to come up with candidate options for shear wall locations, trained on a bunch of different engineering layouts for shear walls. So given a boundary outline and sample projects, we can then generate options. And it's not just one option that we can generate. It's actually hundreds of options based on these training samples. And it's not just one layout, it's really any layout. So we could take what we learned from the way that engineers have designed in the past and then apply that to thinking about or provide some inspiration to help inform the new process. But when we showed this to engineers who do lateral design, they emphatically did not want us to pursue it. This is one of those cases where we started a discussion and got to a solution where we could offer some technology and surface those relevant designs from past projects, but then leave the creativity to the engineers. We found this nice balance. We didn't push our ideas onto them, but really offered a suggestion to spark conversation, and then collaborated on what was the best technology fit. So it's sort of like product market fit. And it was kind of clear after that there's going to be some processes that should remain human, and then other opportunities to maybe do things more agentically or autonomously. There are places where we accept risk or places where we want to accentuate creativity. For whatever reason, there'll be a lot of different processes, and there's no one size fits all solution. We have to be curated in how we use AI across the spectrum. So let's rethink our approach to intelligence and how to spend our development effort wisely. When ChatGPT first came out, we were asking engineering questions, and it really didn't give a response that we were satisfied with. So we were starting to think about what it was that we would have wanted and how we'd like to use it. And it was more like being able to tap into our functions. It would be able to take what it was that we wanted and find information from our domain, from within our documents, or use our own tools, and do that in a way that felt natural. In order to do that, we thought about the design of the system and what differentiates us. We can't compete with all these large capital expenditures from OpenAI, Meta, Google, Microsoft, and everyone else. So how do we focus our energy and our effort on something that we can control and customize? As a result, we came up with our own ChatGPT clone that allowed us to do all the things that we expect within our data security fence. So engineers could ask questions, and then we could build features onto that and customize access to other resources. There's a lot of low-hanging fruit use cases that are very well suited to this sort of thing. Otherwise, we would have had to build a custom tool, and now it's just a prompt into that interface. This kind of took off. We have about half of our company who have at least tried it, and it's a really high engagement rate, 41%. So pretty decent usage. Even week over week and month over month, we're getting more and more engagement as people understand the value it brings. Now that we have this foundation for the things that we can customize, there's this amazing thing that I think has a lot of potential because we want to be able to tap into our functions and control different software. MCP servers allow us to do that. They're basically wrappers around API functions, and they provide the documentation for an agent to use that tool. So now language models can interact with our software for us. We've been experimenting extensively with various MCP servers, attaching to different types of software and controlling them. Each one is very powerful and allows us to do things from within chat in a new way. And it's not just the variety of different software we can attach to. The amount of things we can actually do is quite interesting. From high-level prompts without saying specifically how or what to do, the AI can reason through the tasks. Given the resources it has available, it can reason through a checklist of what it should be doing and then execute those steps as necessary. So in this case, it's not just interfacing with eTabs, it's getting those results, figuring out what the person needs, doing unit conversions, calling Emulation Lab to do the design, and then instantiating the elements in Revit. There are a lot of different actions pulling from different resources. This starts to introduce a new paradigm. And it's the first time I think we've really started to see the possibility of this Jarvis moment, where we can control everything and go from intent to execution. You have a lot of different resources available, and it's honestly kind of overwhelming to think about how we would orchestrate all of these different things at scale. Can we just add all our tools to this chat agent? No, it's not scalable right now, not with current context window limitations and token usage. So we've come up with a more targeted solution. The user has to know what workflow they're pursuing, but within that scope, they can really do whatever they want. It's more of a customized solution at this point. We consider specific use cases, and then we can make these orchestration workflows feel almost magical. So let's talk about data for a minute. We'd like to be able to access all of our projects and search them more naturally. When we are working on a project, we may want to find other projects that have similar characteristics, similar to what we came to in Trace. People tend to do this for projects they have worked on in their own personal memory. But what if we could do that across all projects? The reality is that many of these projects exist in formats that aren't really useful to us yet. They need a lot of curation still to make that possible. We have a vision project for turning PDF drawings into 3D models. It's still more of an augmented process with image recognition techniques used to detect grids, columns, and beams from drawing sets. The detection is quite good and will continue to get better as the users find and correct mistakes. It's dramatically easier than trying to build one of these models manually, that's for sure. There are many components to a drawing set. We can also extract general notes, details, schedules, and all of this data becomes searchable. We've actually had really great success with our project search agents, especially for searching typical details or project-specific details. Searching for details is a very popular use case within the app. We have about 1,000 typical details in our library. With just 1 week of development, we were able to dramatically improve the search process. Engineers can actually find what they need to now within seconds. So given all these capabilities, we need to rethink user interfaces. This is what I think about when I think about engineering software. Engineers need access to all these controls, all these very specific parameters to do various things. They may not need every single function that's possible, but they want to be able to access any of it anyway. And usually the interface feels like this, confusing, overwhelming. I actually feel a lot of anxiety when I look at this, but I won't pretend to know what's involved with flying a plane. I'm sure they need to memorize what every single dial and switch does. It's even worse when all these functions have been buried down into different tabs and menus. It especially drives me crazy how every software has their own layouts and naming conventions, which are all slightly different. So is there a better way? How do you allow engineers the ability to monitor and adjust any parameter they want, but also provide a simple, clean, and intuitive interface? I'll show you one exploration. This is kind of a toy problem, but it's meant to explore possibilities. What if a sketch could be an input? How can we go from sketch to analysis? This was very common when we learned engineering in school. Everything started with simple sketch models. Now we're able to take these sketches and extract calculations from them. Our vision models can recognize all sorts of support conditions, loads, span lengths. You can erase part of it and make changes. So now we can use a hand sketch to perform some basic engineering analysis for common engineering problems. But there are a lot of limitations to doing it from paper with a camera setup like we had initially. What's more practical is a digital sketchpad. That's what we did here. We created a sketch interface where engineers can construct and sketch what they want to analyze. It's detecting what they draw and translating it into native components that people can edit. So it's similar to experience we were just showing, using the same underlying models. But now we can do a lot more. We can customize and edit and tweak these sketches. Depending on what the user likes to do, if they want to sketch, they can sketch. If they don't want to model traditionally, they can model traditionally. And if they want to describe it in chat, they can do that too. We're letting users define their own experiences and how they want to interact with the underlying functions. They can work very quickly. These workflows become almost disposable. They can study something very quickly, and it gives them something to build upon. All of this is powered by Emulation Lab, by the way. So all that work we did years ago, we get to reuse it. We can just think about new ways of working. The design functions we created can be used here too. You can create them the same way from chat if you like. We've introduced a viewer so you can design, test, and go from sketch to final analysis, interrogating your models in various ways. This is really just the beginning, but it starts to open up entirely new possibilities for design orchestration across silos. By combining all these solutions together, chat, MCP, vision, and tapping into a rich ecosystem of custom tools and agents that our company creates, we're enabling fresh ideas about process with advanced levels of control and customization. Engineers can focus on intent and creativity, while the system handles the orchestration and task execution in a traceable way. I hope I've shown that we use technology to support project delivery even though what I've shown today doesn't directly touch projects in the traditional sense. Our goal is to integrate with our teams and processes, to free them up for creativity. And if the tech doesn't work for them as it exists, we'll make it work for them. But really, one of the big lessons I've learned throughout this process is that technology is only part of the solution to drive impact. It's largely a people problem. We have stakeholders across the company that we've been engaging throughout this entire process. Technical teams, business leaders, other digital initiative partners, different practice areas, content managers, IT, leadership, various project managers and subject matter experts across global regions, and of course, the end users who will be using these tools. Ultimately, literally everyone is a stakeholder in the work that we do. And it's not always easy, but it's something we're continuing to learn and navigate as we go. Thank you.
Thank you, Dan. That was quite amazing. I'm still not sure if you can hear me. Can you hear me?
Sorry,
Okay.
no, I can't hear.
You still can't hear me. Can you still take question? I am, first of all, thank you so much for sharing that. I am not sure if anybody, if we can do the Q&A because of the audio issues. But Dan, can you see the chat box in the attendance chat? And yes, thank you, everyone. It is impressive. Dan did. I was excited about sharing this particular presentation because we had Dan do this presentation for us in New York sometime last year. So I'm really excited to be sharing this with you today as well. And obviously, there are so many other changes and updates since that last presentation as well. Okay, we don't know if we're able to do this. I'm posting questions. Okay, hold on a second. It's on the attendance chat. Can you see it? Hang on, everyone. I'm also thank you for so many of the feedback. Everybody else is really loving the presentation. We're trying to figure out if we can do a Q&A session with Dan. Okay, got it. I understand. Sorry. Let me just ask Dan some questions. I'll be looking ahead. Okay. Looking ahead, which emerging AI capabilities do you think will have the most transformative effect? Hey, Dan? Yes.
Are you able to hear me?
Yes, much better. Thank you.
Okay. So looking ahead, which emerging AI capabilities do you think have the most transformative effect on engineering practice in the next 3 to 5 years? I guess the question is which ones will last, and so it's more. Maybe it's partly about what is possible, but then also about what will our users will want to see, and they certainly want that control and customization aspect. And agentic processes have a lot of potential, but how can we put guardrails on them and make them transparent so that we can balance the needs of speed and trust? Um, there, there's certainly one area that we're going to be focusing on is in that orchestration and enabling, um, those customizations to our particular tools, which is going to take time to develop. So, um, hopefully, those that develop software will enable API usage or develop their own MCP servers in a way that can be compatible with each other. And, how do we, so I can understand the ways that we need to work within our firm, but then I think there's also possibilities about how we collaborate across firms. How architects, engineers, contractors uh, can all start to improve the processes across our and build trust across those platforms. How we share data, how we interact. Are we going to have agents that interact for us across companies? I don't know. Um,
Interesting
Another
perspective.
one, which areas of everyday engineering work have you seen AI make the most tangible impact so far? And where do you see the biggest gaps between AI promise and practical results? So if we're talking about generative AI, then I think basically low risk areas where um, you need to handle formatting can be really useful. Um, so if you can, the one example that I shared was plan check comments, and ultimately we wanted them in a table so that we can go through and sort of check off when we have completed each one. And we were able to just prompt that into the chat and get a table. Um, of course, we could also just kind of convey that information in a table to begin with, right? But uh, it's these little things where I think it kind of makes our lives easier and are tedious, but they're not really. It's okay, maybe, or easy to review to see when they're wrong. Okay, another question. With trust and verify approach, once AI generates a solution, how much resources required to verify as a percent of developing the solution without AI? Yeah, so that's a good question. I mean, I think we, as a percent, that example with the spread footing design, the Gemini was able to use 30 seconds and create a tool, right? Created a Python script that then we could immediately plug in and get results. But in order to verify it and like we kept finding issues, like we would test it. We had to have basically ground truth to test it against. It was getting things wrong. So we had to dive in and troubleshoot it. And it was possibly worse than just doing it ourselves from the beginning. What is really good at with code is documenting, because people are really bad at documenting, and so there's definitely a place for this co-creation um, if you can learn to be effective. Right now, the tools are going really, really fast, and it's kind of hard to keep up and feel grounded in um, establishing a process with guardrails. So we have some people that start trying more and more people try to code because they're using these co-creation methods, but then they end up coming to us with the code to try to fix it. So I think it's really good to have participation and share ideas. And in the end, we're better off for it, but we're still very inefficient in the way that we uh, co-create, and especially we don't have the language, really a shared language to be able to communicate about those ideas. Um, so it's really great, I think, in prototyping because I can vibe code some app that is harder. It's easier to show than to explain. Um, we used to do other prototyping, you know, to do this, right? You could sketch something, um, but now we can make almost a functional prototype, which it's not ready for production, but it expresses an idea. And so I'm really excited about that way of working. So either I want to be able to either it's opening up some new capability that I didn't have before, or if I know the result to expect, I can verify immediately that the results are correct or not, so I can troubleshoot and work through those issues. Those are basically two really strong ways right now that I found. I'm not seeing any new questions.
I'm just checking to see if Dan can see the other questions too. But if not, then we may have to conclude this shortly. Okay.
Thank you.
We want to thank you again for Dan for doing this presentation with us, even though he can't hear us. I'm so sorry, but I'm so glad he was able to share this with you. It's been a fantastic presentation and love seeing what Walter P. Moore is doing. I also wanted to call out to those that are joining us. We have a few other things lined up in the next hour. We have the Workshop XR, how it transforms AEC Design Review. That's the new tool for the design workflow and the XR AR/VR that Autodesk has done. So that's coming up at 12 p.m. Eastern Time. So I just wanted to say thank you on behalf of Great Tech and on behalf of Dan. Thank you for joining us today. We appreciate your tuning in and have a great day and see you in the next session. Bye, everyone.